Hello students. All right, we are now going to continue on our lesson with proportion. I'm going to add one more example here. We're going to write down, or actually not example, but we're going to write down the formula for proportion. And let me just rewrite that. So the formula for proportion, there are two letters that we like using, or two sets of letters. The first one is the letter P, and then with a proportion to Q. You're going to see those two letters a lot, so that's why I'm writing it now. And of course, we're all familiar with the good old X and Y. And so now let's get into what I'm going to use these formulas to kind of explain a couple of things, and we're going to write some things down in the form of these formulas. So we're going to start with, or continue our lesson with, direct proportion. And direct proportion is when the increase or decrease of one variable affects the other. All right. So for example, let's do an EG right here. So in example, we have P is equal to Q. So we're going to say like, the amount of whatever P is equal to the number of Q. Another example though is if, or actually, within those lines, if you, let's say, multiply P by 2, what would happen to Q? And so then the idea is Q should also multiply by 2. So therefore, you'll get that 2P is equal to 2Q. We had an example of this in the class where we talked about the teacher and the students. So we're going to briefly just add that into the list here. We're going to add a table, and we're just going to add 4 slots here for the table. So if you guys could copy this down. And let's say earlier in our example, we had the number of teachers, which in this case will be, it'll be the letter P. And we had the ratio of that to students, which is the letter Q. Then we had a 1:8 ratio. So for every 8 students, you have to have 1 teacher. All right. And so then we saw earlier that, well, if we have 16 students, then we should have 2 teachers, and so on and so forth. So then 24 would make for 3 teachers. And lastly, 32 would make for 4 teachers. So you're going to need 4 teachers for every 32 students. Now, in this case, you can see that because the numbers increase evenly. So every time we increase by 1, we get 8 increase right here. Then because of this, this is a direct proportion. Now, we could also look at numbers that are not direct proportions, and I'll make a smaller table here. But let's say we have the teachers and students, but this time we're not going to go all the way. We'll just have 3 slots that we're going to fill out. So let's say at this point, we have the P, which is the teachers. All right, I'm just going to write that down. Teachers. And the students, which is Q. And let's say we have, for 1 teacher, we had 8 students, and then for 2, we had 16, and then for 3, we had 25. So now, if you take a look at the number here, you'll notice that there was an +8 increase here, or a multiple of 8. But then once we got here, then if you notice, it's adding 9. So this is not a direct proportion. All right, so with that, I'm going to zoom out a little bit there, but you should be able to see these tables here, and you should be able to identify the different types of proportions. So one thing that we're going to try is, let me just pull this up. So this is all listed in the in the textbook. And something that I would like you to do is try page 287. So we're going to see how we could turn this into a formula. Actually, right before that, what we'll do here is we're going to add one more thing. So we are going to look for something that is called, there are a couple of definitions that we'll need. I'd like to point out that fractions can be written, or proportions can be written as fractions. So let's write that down so that we could keep that in mind. Proportions can be written as fractions. So the rule here is if you have something that is ratio P to Q, then you are going to write it as Q over P. This is something that's important for us to know. You could actually write P over Q as well, but we're going to see that the ratio proportion here, or the proportion, there'll be something called a constant proportion that we'll talk about. So in other words, having this formula does really help. So one thing that I would like you to try to do right now is I would like you to try turning these numbers into fractions. So I'll give you 4 questions here. So we're going to have 1 to 2. I want you to try then 2 to 5. And then, 3 to 6. And 4 to 12. All right. Now, at this point, you could pause and give it a shot. I'm going to write the answers out in a bit. Let's see if you guys can answer it. So you can pause now. And welcome back if you did pause. So if we were to write this down, then the ratio would be, let's see, Q to P, right? So the letter Q, that's the back number. That would have to go first. And then you're going to have the other number right there. So it's 2 to 1. And we got 5 to 2 on the second question. Now the next one is 6 to 3, but you could also simplify that and make that 2 to 1. And the last one here, we're also going to simplify it, 12 to 4. So you're going to get 3 to 1. Ideally, these numbers you do want to simplify. We're actually going to mostly make that a rule of thumb here. We don't really deal with mixed numbers, so you can kind of rest knowing that once you have this fraction, you're done. It could sometimes be a fraction if it's over 1. Sometimes you could even simplify that into a whole number as well. But we'll talk about that in a little bit. So right now you're going to have a little bit of a practice. Please do the try questions. And I'd like you to do the try questions on page 287. So you're going to go ahead and complete these notes by doing this, and we will continue our lesson in class tomorrow. All right, see you guys.